Alright, let's kick things off by discussing the definition of a group. In mathematics, a group is a set equipped with a binary operation that satisfies four properties: closure, associativity, identity element, and inverse element. So for example, if we have a set G and a binary operation to be a group, G must satisfy these properties. Does that make sense so far?
Yes, Sophia. So, for instance, if we take the set of integers under addition, does it form a group?
Exactly. The set of integers under addition forms a group because it satisfies all four properties. Closure. The sum of two integers is always an integer. In associativity, addition is associative. Identity element identity element, 0 serves as the identity element. And in the inverse element, every integer has an additive inverse. Now, can anyone think of an example of a set that doesn't form a group?
How about the set of natural numbers under subtraction? It doesn't have an identity element, right?
Precisely. The set of natural numbers under subtraction fails to form a group because it lacks an identity element.
Proving elementary properties of group. So, alright, my objective is to prove the elementary properties of a group. Let's start with closure. Closure means that when you perform the binary operation on any two elements in the set, the result is still in the set. For example, in the set of integers under addition, if we add any two integers, the result is always an integer. How would we prove this property rigorously? We could take arbitrary elements A and B from the set and show that there's some A plus B still in the set. And so let's suppose A and B are arbitrary integers. There's some A plus B is also an integer. Integers under addition satisfies closure.
So our next objective is constructing Cayley tables for finite groups. My objectives is to construct and complete Cayley tables for finite groups. A Cayley table is a way to represent the binary operation of a group in a table format. Each row and column corresponds to an element of the group, and the entry in each cell represents the result of applying the binary operation to the corresponding elements. For instance, let's construct a Cayley table for the group of integers modulo 4 under addition.
We can start by listing the element of the group 0, 1, 3, and 2. Then we can perform addition modulo 4 for each pair of elements and fill in the table accordingly.
Precisely, Justin. Conducting Cayley tables helps us visualize a group's binary operation and understand its properties better.
So using elementary properties to prove related propositions. Alright, my objective is to use the elementary properties of a group to prove related propositions. Let's consider the propositions in a group. The identity element is unique. How would we prove this?
We could assume that there are two identity elements, E sub 1 and E sub 2, and then show that they must be equal.
Exactly, Sophia. So if E sub 1 and E sub 2 are both identity elements, then E sub 1 times E sub 2 equals E sub 1. and E sub 1 times E sub 2 equals E sub 2. Therefore, E sub 1 must equal E sub 2, and the identity element is unique.
So my objective is using technology to communicate solution. Last, Lastly, my objective is to use technology to communicate solutions and prove to the whole class. We can utilize platforms like online whiteboards or presentation software to share our solution and proofs effectively. This way, we can collaborate and learn from each other approaches. Online whiteboards offer a dynamic space where we can brainstorm ideas, draw diagrams, and work through mathematical concepts collaboratively. With features like real-time editing and commenting, everyone in the class can contribute their insights and suggestions, fostering collaborative learning environment. Additionally, online whiteboards often provide tools for organizing information neatly, making it easier for classmates to follow along with our explanation. Presentation software, on the other hand, allows us to create visually appealing slides to present our solution and proofs. We can include text, images, graphs, and equations to illustrate our points effectively. Presentation software offers various customization options, enabling us to tailor our presentation to suit the content and audience preferences. Moreover, we can easily incorporate multimedia elements such as video or interactive simulations to enhance the learning experience further. Conclusion: by discussing binary operation, groups, elementary properties of groups, and utilizing technology to communicate our solution, we covered all the learning objectives. Truly understanding this concept and techniques will enable us to delve deeper into group theory and its application in mathematics.